So guys, till now you have seen two types of graphical representations, bar graphs and histograms. Now there is yet another way of representing data graphically. It is the frequency polygon. Does it mean the polygon which represents frequencies? Yes, a frequency polygon is a polygon which represents the frequencies of a data set. But where exactly is the polygon here? Well, if you carefully see, this is a polygon, as this is a closed figure bounded by straight lines. To know more about frequency polygon, consider this histogram. Now just follow what I am doing. Mark the midpoints of the upper sides of the rectangles. Let us name these midpoints as B, C, D, E, F and G. So we get 6 midpoints. Now join these midpoints using straight lines. So join BC, CD, DE, EF and FG. Thus we obtain the figure BCDEFG. Now tell me if it is a polygon. No, because a polygon is a closed figure. So to complete the polygon, we assume that there is an interval before the first interval with frequency 0 and one interval after the last interval with frequency 0. Let their midpoints be A and H respectively. Now join AB and GH. Thus, ABCDEFGH is the frequency polygon corresponding to the data represented by the histogram. It was easy, right? We just joined the midpoints of the rectangles and we got the frequency polygon. But the question arises, how do we complete the polygon when there is no class preceding the first class? Let us look at such a situation. Consider the frequency distribution table which represents the marks out of 100 obtained by 51 students in a class test and the histogram corresponding to this table. Let's again draw the frequency polygon the same way as we did in the previous example. Mark the midpoints of the top of the rectangles as B, C, D, E, F, G, H, I, J and K. Now join these points using straight lines like this. As we can see, the polygon is not complete. So to complete the polygon, we have to join the point B to the midpoint of the previous interval and the point K to the midpoint of the next interval. But there is no interval before the first class 0 to 10. So what shall we do now? Well, to find the interval preceding 0 to 10, first extend the horizontal axis in the negative direction. So we get the markings as -10, -20, -30 and so on. Then find the midpoint of the imaginary class interval -10 to 0, which is clearly -5. So guys, we got the required midpoint. Remember that this class interval has frequency 0 because this class interval is not mentioned in the table. Now join B to -5. The point where the line segment meets the vertical axis is marked as A. Further, let L be the midpoint of the class 100 to 110 having frequency 0. So join K to L. Thus, OABCDEFGHIJKL is the required frequency polygon. Interesting, isn't it? So now you know what frequency polygon is and how it is drawn. But do you know frequency polygons can be drawn independently without drawing histograms? Yes, you heard it right. We don't need to draw a histogram to draw a frequency polygon, thus saving a lot of time and energy. Want to know how this is done? Catch me in the upcoming video. Now, let's do a quick recap. A frequency polygon is a graphical representation of data. In a frequency polygon, the number of observations is marked with a single point at the midpoint of an interval. A straight line then connects each set of points. To draw a frequency polygon over a histogram, first Mark the midpoints of the upper sides of rectangles. Then, join these midpoints using line segments. To complete the polygon, assume that there is a class interval before the first class and a class interval after the last class having frequency 0 and mark their midpoints. Lastly, join these midpoints to the previously drawn points. Thus, the frequency polygon is obtained. In case there is no class preceding the first class, extend the horizontal axis in the negative direction. Then, join the midpoint so obtained with the previous point. Thus, the required histogram is obtained.